Today we're going to finish up section 3.1, and it's kind of nice because we still get to review what you learned at the beginning of 3.1 about finding critical numbers in order to do this new part, which is finding the extrema on a closed interval. So extrema, if you remember from that first day of 3.1, if we're looking between the interval of A to B on the x-axis, and maybe we have a graph that looks like this, then it's extrema, it's extreme points, it's absolute min and it's absolute max. The min would be found right here, the absolute min, and it would be at a critical number, because that's at a relative min there. But the max right here would be found at the right endpoint. So extrema on a closed interval could happen at endpoints, and it could happen at critical numbers. So we still get to practice finding critical numbers. So this example, find the extrema of f of x equals 3x to the fourth minus 4x to the third. Right away, we're a little bit relieved because this is a polynomial function, so we know the derivative is going to be nice. So first thing we do to find extrema is we're going to take the derivative so that we can find the critical number. Okay, so our derivative is 12x to the third minus 12x squared. We said since it does not have a denominator, we don't have to worry about getting a fraction, so we'll just set the numerator equal to 0. And we want to factor. We want to solve by factoring. Super important. So we will factor out the GCF. Set those factors equal to 0. Divide by 12. Take your square root. And since it's 0, there is no plus or minus. That just has a multiplicity of 2, if you might remember from last year. And this other one, you set it equal to 0 and solve. So we have two critical numbers. So possible critical numbers. And I forgot to tell you the interval. We're looking at the interval from -1 to, I can't see it very well, -1 to 2. So that is our interval. That's our A and our B. That's our left endpoint and our right endpoint. So -1 is the left endpoint and 2 is the right endpoint. So we're going to make a little chart. Left endpoint. This time we found two critical numbers. Put them in the middle. And then right endpoint. Because these critical numbers would have to fall somewhere between A and B, our left and right endpoint. Sometimes they don't, and we would say, oh, we don't get to use this critical number because it's outside of the range. Like if we found x equals 3 to be a critical number, we'd say, well, we can't count that because it's not in the -1 to 2 interval. But in our case, both of these are. So we're going to do the function evaluated at the left endpoint from the bracket, the function evaluated at 0, the function evaluated at 1, and the function evaluated at 2. So, and I did put the critical numbers kind of in order. I just like to do that, especially for where we're headed on Wednesday. And we can do this multiple ways. One way is we could put this into our y equals on our calculator, and we could just check the table for all these values. I don't have my calculator with me, so I'm going to have to just plug it in. So -1 to the fourth is 1, times 3 is 3. -1 to the third is -1, times -4 is 4. So we get 7. for 0, we get 0. For 1, we get 3, 3 minus 4, so we get a negative 1. And for 2, we get 16 times 3 is 48, minus 8 times negative 4, 32. So these are the actual function values for these left endpoint critical numbers. So you see that this is the minimum. Negative 1 is the smallest value that we got. So it's our absolute minimum. So we have an absolute minimum at x equals, well, we could put it as an ordered pair, at x equals 1, but the ordered pair would be 1, negative 1. And you don't have to write them as ordered pairs. I just want you to put minimum here. And 16 is the highest value, so that's our max. So we have a max at x equals 2, or at the point 2, 16. So they're kind of nice. So I kind of left off my steps, didn't I? So step 1, take the derivative to find the critical number. Step 2, I guess, would be make the chart. And find the function values. Sorry, that's kind of crowded. Make the chart and find the function values. Okay, let's do another one. Maybe this one is not a nice polynomial. Let's see. Yeah, f of x, this is example 3 in the book. F of x equals 2x minus 3x to the, can't see that power very well, to the 2/3. And we're on the interval from negative 1 to 3. Okay, so if they want us to find the absolute extrema, or they might just say the extrema, we're going to take the derivative so we can find our critical numbers. They've already written this in a nice form for us, so it's just 2 minus 2/3 times 3 is 2, negative 2x to the negative 1/3. Then we want to write that with a positive power. So it's just the x that moves. 2 doesn't have that power. And then we need a solid fraction here, so we're still doing that work that you did for me on critical numbers at the beginning of 3.1. So I'm going to butterfly to get this as a fraction. So it's 2x to the 1/3 minus 2 all over x to the 1/3. And then to find the critical numbers, we set the numerator equal to 0 and the denominator equal to 0. In this case, we can factor the 2 out, or we could just solve it because x is less than 2. I think I'll factor today. So set both those equal to 0. 0 is 2. No, it's not. And 0 is x to the 1/3 minus 1. Add 1. Cube both sides to get the x free. So 1 is x. We could have just moved the 2 over and divided. We could have just solved here. Here we would cube both sides to free the x. So we have 2 critical numbers, and both are in this interval. So we're ready to do our chart. Because 0 and positive 1 are between negative 1 and 3. So the left end point is negative 1. The first critical number we would come to would be 0. The next critical number would be 1, and the right end point is 3. You can plug this into y equals and check your chart. So, again, I don't have my calculator, so plugging a negative 1 in for me is negative 2. A negative 1 to the 2/3. Negative 1 to the second power is 1. Cube root is 1, so it's minus 2. So I think it's negative 5. 0 gives me 0. 1 gives me 2 minus 3, or negative 1. And 3 gives me 6. 3 to the 2/3. 3 squared is 9. The cube root of 9, it's not a perfect cube. Cube root of 9. A calculator would be handy here. Times 3. Oh, I could do 3 times 3. When I multiply like bases, I add exponents, so that doesn't help me any. Let's use our calculator. I'm going to cheat and look in the book. It is approximately negative 0.24. So just letting the calculator work that out for us with a 3. And so then you compare the values. And actually 0 is the biggest of all of these. And negative 5 is the smallest. So there's our min and our max. All right, we have one more. It's a trig function. 2 sine x minus cosine 2x. And our interval is 0 to 2 pi. So one nice thing about this chapter is we are still doing derivatives. So we're still doing product rule, quotient rule, chain rule. We're still doing derivatives, so we still get to practice finding derivatives. We're just applying them in this chapter. We're seeing all the ways we can use derivatives. So the good news is this trig function is going to work the exact same way to find the relative extrema. We're going to do our derivative. This one's a nice one. This one's chain rule. So the first one is 2 cosine x. And now we're going to do chain rule. So the derivative of cosine is negative sine of the angle times the derivative of the angle. So when we clean that up, we're going to get plus 2 sine 2x. Nothing factors out except for a 2. They do something really tricky here. God bless you. Sorry, I heard my husband sneeze in the background. That's why I say God bless you. They do something tricky here that we may not remember from pre-cal. The sine of 2x, it's a trig identity. It's equal to 2 sine x cosine x. Unless this pops up a lot in our homework, I wouldn't do a trig identity like this on the test. So it's 2 cosine x plus, I already have a 2 here, multiplied by this 2. So that gives us 4 sine x cosine x. So that is tricky. And unless it pops up a lot, we won't have that on the test. Now we can set it equal to 0, factor out the GCF, which is 2 cosine x, and we're left with 1 plus 2 sine x. So now we'll set both of these factors equal to 0. And this is a reminder of some stuff we haven't done in a while. We are going to solve for cosine x. So we're dividing both sides by 2. And then we look at our unit circle chart to see where cosine is equal to 0. So let me just take a picture of my chart so we can all look at it. You have one in the front inside cover of your book. That's where I'm looking right here. Okay, where is cosine equal to 0? Well, we remember that ordered pairs are cosine for the x and then sine for the y. So we're just looking where cosine is 0, and it happens right here and right here. And they restricted us in the interval 0 to 2 pi, so both pi over 2 and 3 pi over 2 are acceptable critical numbers. X is pi over 2, and x is 3 pi over 2. This one, we are going to minus 1, and then divide by 2 to get that sign equal to sine x by itself, because we're trying to solve it for sine x. Then if you look at your unit circle chart, where is sine equal to half? Negative a half. Let's see. Sine is negative a half right here, and it's negative a half right here. So 7 pi over 6 and 11 pi over 6. And that's been a while since we've done that, but we are going to do that quite a bit in this chapter. So ask me Wednesday if that's a little iffy. Now we have to set up our chart. I'm going to just erase all this top part. We have 4 possible critical numbers and our left and right endpoint. So this is a big one. And I like to put them in order. So left endpoint, 1, 2, 3, 4 critical numbers and a right endpoint. Left endpoint is 0. The first critical number is pi over 2. The next critical number is 3 pi over 2, and we could look on the unit circle to help us to get these in the right order. The next one is 7 pi over 6. And the next one is 11 pi over 6. And the right endpoint is 2 pi. Oh. So I'm not a very good chart maker. I never have been. All right, so we would probably definitely plug that derivative into y equals and let the calculator do the work for us. And I've erased what our derivative was, but it was 2, I'm looking back, 2 cosine x plus 2 sine 2x. So we would plug this into y equals, and then we would look at our chart. And since we're dealing with radians, this is not going to show up on our table as is. So we would do that second table set, which I believe is above window. And then we would go down 3 lines to independent. And we would go over to ask and highlight that. And then we would do second table. And it brings up the blank table for you. And you can enter all of these x values. So you'd enter 0, you'd enter pi over 2. Pi is somewhere around the division button. And you'd enter all these in. And you could just write down whatever those decimals were over here. You could write down whatever those decimals are. Actually, they might be nice numbers. I do have the answers. It'd be a -1. Pi over 2 would be 3. 3 pi over 2 is -3 over 2. 7 pi over 6 is... Oh, I got that backwards. 3 pi over 2 is -1. Oh, because I don't have these in order. 7 pi over 6 is -3/2. 11 pi over 6 is also -3/2. And 2 pi is -1 again, because 0 and 2 pi are in the same spots. So our smallest is tied right here. We've got 2 that are tied for minimum, and our max is the 3. And that's okay. We could have 2 that are tied for a minimum. Alrighty. Good luck. Do your best on these, and we will get together on Wednesday, and we will go over any questions you've got.